Moving to the country, I'm gonna eat a lot of peaches. I'm moving to the country, I'm gonna eat me a lot of peaches. I'm moving to the country, I'm gonna eat a lot of peaches. I'm moving to the country, I'm gonna eat a lot of peaches. Peaches come from a can.
That's right, we're going to talk about how to put peaches in a can. So here we have an example of growing peaches in groves and shipping them to processing plants to be processed and put into a can by a man in a factory. So that's the key. So take some time to write out the linear program on your own. And once you do that, you'll notice that there are 9 different variables. There's different ways we can ship these. Mount Dora to the 3 different locations, Eustis to 3 different locations, and Claremont to 3 different locations. Those are number of bushels. Well, each location from Mount Dora to Ocala is miles. And so we're trying to minimize the bushel miles, or the miles that each bushel of peaches travels. We have 6 constraints. One is that all the peaches must be shipped. Those are the first 3. And then the last 3 are we cannot exceed the capacity at any individual factory. So to start with this, I'm going to grab this whole thing right here. I'm going to copy that. And I'm going to throw it into a new Excel worksheet. I'm going to call this LP Example 5. All right, so here, let's open this up a little bit more. Right there, let's do that again and throw it down here. All right, so I'm going to delete all of these, and I'm going to call these right here my variables. So X1 is going from Mount Dora to Ocala. X2 is Mount Dora to Orlando, and so on and so forth. All right, so there I have, I can even put this right there. All right, so this is the amount I'm shipping between the different groves. All right, my objective is to minimize bushel miles. So I have total distance in bushel miles. All right, and I want to minimize that, so I'm going to jump that just a little. And this is now equal to the sum product of all 9 variables, comma, all 9 distances. And that's going to give me bushel miles. So I'm going to turn that to green. And that is my objective. Now my constraints. So one constraint is that there are a number of bushels at each place. So I have a supply. Well, Mount Dora, I have 275,000. Here I have Eustis, 400,000 bushels. And here I have 300,000 bushels. I need to ship all of those out. So this is equal to the sum. All those that I ship out from Mount Dora. All those that I ship out from Claremont. And so I need each of these individually to be less or to be equal to those. So there are my first 3 constraints. X1 plus X2 plus X3 is equal to 275. Well, next I have, let's add a quick thing here. I have capacity. Each plant has a capacity. This plant in Ocala has 200,000. 600, that's a good sized plant in Orlando. And then 225,000. Okay, so those are that. So I can do something like this. Put that in an outside box. And then this is bushels received. That's going to equal to the summation of all those that come to Ocala. And I can bring those all the way over. And so now here are 2 more sets of constraints that I have. So here is my linear program. Put things a little nicer. And so my objective is to solve to minimize bushel miles by changing all 9 variables. And then my constraints are everything that, oops, no, I'm sorry, over here needs to equal the supply I have. And then all those received at the different plants need to be less than or equal to the capacity at the different plants. Simplex LP. Oops, I don't need help. Oh, it's giving me help. I don't need help yet. Trust me. I'm just going to hit solve. And there we go. This is the optimal strategy to send. I can then run my sensitivity report. And here you have it. So if I bring this over, this tells me that bushels received in Ocala. Notice that Ocala is at capacity constraint. So if I can increase the capacity by 1 unit, it will decrease the total bushel miles by 27. So that is one place I want to increase capacity. At Orlando, even though it's the biggest plant, I'm only shipping 550,000 there, and so if I increase the capacity, it'll have 0 impact on my bushel miles. I'm also at capacity in Leesburg. So if you increase the capacity at Leesburg, it'll decrease the bushel miles by 8. So if it's equal cost to increase the capacity size of each plant, you would want to increase the capacity size at Ocala, because for every additional bushel it can receive, it'll reduce the bushel miles by 27 miles. Now next we have the supply, and so this tells me if I have more bushels at Mount Dora. All right, so I have 275. I'm shipping all of them away. For every additional bushel, it's going to increase bushel miles by 48. Eustis at 30 and 20. So if I have the opportunity to expand an orchard, expand a grove, and produce more, I actually want to choose Claremont if they're of equal cost, because for every additional bushel I create in Claremont, it's going to increase bushel miles by 20, which is the smallest of the 3. And so that's how we can use the shadow price and the sensitivity analysis to make some consulting advice. Oh, and now that we have that, let us please continue with the song.
They were put there by a man in a factory downtown. And if I had my little way, I'd eat peaches every day. Sun-soaking bulges in the shade. Moving to the country, I'm gonna eat a lot of peaches.